in any system, the whole system has to kind of work together as a whole. But you start getting bits kind of break away and everyone's working to their own kind of intent, their own goals, their own end. And it becomes a bit fragmented, and then it becomes harder to keep any kind of a story going. This photo, 408 kilometers, and it's taken, let me just scroll down, it says exactly here, from the top of Neuffonce, and it's a picture of the top of Estrop. So then, I'll have a look at this. Neuffonce, Estrop. Okay, so what have we got? Let's go back there. So that is the top of Estrop in the Alps of Haute-Provence. Photograph from Neuffonce in the Pyrenees, 408 kilometers in between. So Neuffonce is where the picture's taken from. As an elevation of 2,851 meters. Then we go on to the Earth curve calculator. 2,851 meters is what it was. So change that to 3. Let's say the person's about 6 foot tall. So now we're assuming it is on the highest point, which is 2,851 meters. We're assuming that they're 2 meters tall, so that now makes it 2,853 meters. Target distance is 408 kilometers away. So then, for you to be able to see something, you're standing 2,853 meters in the air, and you're looking across a distance of 408 kilometers. For you to be able to see anything past the curve of the Earth, that thing would have to be above 3,705 meters. So just for it to be just a little speck just above the horizon, and when you're looking over 408 kilometers, you know, it's like you're not going to see something that is just a little speck above the horizon, because that's such a long distance. Even when you're zooming in, like, it's going to be a long way to try and see it. So there's got to be a substantial amount of it there and visible. So if it's below 3,705 meters high, you're not going to be able to see it. Well, the Strop is only 2,961 meters high. So that is over 700 meters short. There's no way that you can see the top of that mountain while standing on this mountain. All it should be there is the curve of the Earth. But then what people like to say is that the image you're seeing all that way in the distance is caused by refraction. It's kind of like the sky becomes a projector screen. The light's hitting the object, bouncing off of it, and then you get a projection of the object on the sky. And it's not actually there, you're seeing a mirage. The sun's behind it. Why can't the sun shine through a mirage? And even still, that's looking straight across at it. You should be looking down at it, really. So that should be behind the curve. That is over 700 meters lower than the curve of the Earth. I really don't care about refraction or any kind of noise that people want to talk about. That is clearly there. It is clearly present. It is a straight line of sight to it. Where is the curve? And even when you look at these kind of curve calculators, so just move this back a bit, get the 2 points in. You see it's showing that is someone there, and they're at a height of 2,853 meters. Looking across the bulge in the Earth, just to see the very top of it, it would have to be 3,705 meters tall. But it's not. It's 2,961. So it's saying like 750 meters. Too short for you to be able to see it. But somehow, you've got a lovely clear picture of it, as if it's in a straight line of sight with nothing in between. And even these curve calculators are deceptive. Because when you're standing here, are you leaning back? Is that what you're doing? You're leaning back? No, you're not. You're standing here, you're always upright. On the globe, aren't you? You're always upright, everything is upright to you. So then it should have you here, it should have the hidden objects there, and then the bulge in the middle. But then you're looking straight across at it, you're not looking down at it. So if they gave you an accurate representation of you standing upright on the ball, as you should be, upright on the ball, it would then appear like you're looking down to look at an object in the distance. So I just get the monitor. You see, that's what it should look like. That should be where you're standing when the horizon's there. And that's about straight. Is that how you look at things? Because now that's upright. That's you standing upright. Are you looking down to see that thing in the distance? No, you're not. So even in the way that they try to demonstrate the curve, there's an amount of corruption. They're trying to make it look like the bulge is sticking up in the middle, but then that means you're leaning back. But if they put you flat on top of the Earth, then it looks like you're looking down at the hidden object. There's no way that they can give you any kind of accurate demonstration of how things actually look on Earth. Then, that makes you start questioning, doesn't it? To be able to see something from a height where you are, you're standing there at 2,853 meters. You're looking across a space of 408 kilometers. That thing, for the very top of it to be visible, would have to be over 3,705 meters. But it's not. It's only 2,961, but it's right there, and there's a lot of it there. Where's this bulge? Why is there not a bulge? Just look at it on Google Maps. Got that there, that's saying 400 kilometers, but I've clicked on that, which is near to the target object. That is S-drop. It's new fonts. Look at all that. Why isn't it all bulging? Why is there no bulge blocking it out? You can see all the way from there to there. Let's put it on the satellite. You can see all of that, all the way across there. And you shouldn't be able to, because there should be a big lump of earth in the way. There should be a bulge. It's the madness. Like with science, they use all these technical terms and They make things overly technical so you can't understand it, and you just don't understand it because it's too technical. But then when they talk about the shape of Earth, they say it's round. Well, a record's round, a pizza's round, a CD is round, a coin is round, and most of the flat Earth maps you see show that the Earth is round. So if these are such technical people who have to speak in such technical terms, and the only reason you don't understand what they're saying is because you haven't had this mad technical education, then why are they saying that it's round when they mean it's a sphere? Another thing, heat rises, cold falls. So then, does heat gather at the north? Is it hotter in the north and colder in the south? No, it isn't. So it isn't the case that heat rises and cold falls. You see, to say heat rises and cold falls, that only works on a flat surface. When you apply that onto a globe, it isn't the case that heat rises. It isn't the case that cold falls. Because on a globe, if you say heat rises, then the heat should all be gathering in the north. And the bottom, down the south, it should be cold, right? But you say, well, no, because there's no real up and down in space and blah, 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 and when it should be gathered at one point near the equator, or one point somewhere, but it's not. It's evenly dispersed. The reality is that heat is repelled from the Earth and cold is attracted to the Earth. But then that sounds like magnetism, and they don't want to make it sound like magnetism because then it makes it harder for them to push the theory of gravity. So then they use deliberately wrong terms to try and create an image, and that image only actually works on a flat Earth. And then technology advances and people are so proud that their technology is so great and their camera's so amazing. You then get people taking pictures that are impossible on a sphere. You can only take that picture on a flat Earth with a clear line of sight. And you can't say that that's the image refracting because the sun would shine through a mirage. It's mad, isn't it? It's all there in front of you, you just don't realise until it's put together.